NASA's Jet Propulsion Laboratory presents the Von Karman Lecture, a series of talks by scientists and engineers who are exploring our planet, our solar system, and all that lies beyond.
It's a shame, but living in the city, very rarely do you get to see stars.
I feel like I have a new connection to them in a way that I haven't before.
If I'm out in the desert and I look up at the sky, you just see millions and millions of places that we should be going.
The desire to go and explore, right? That's the whole reason why we left the forest and then traveled across oceans just to see what's out there.
I was born in 1969, which is the year we landed on the moon. So I am a space baby.
When I was a kid, there were guys driving cars on the moon. They're driving cars on the moon. That's so cool, right? I want to do that.
All the rocky planets that we know of all have got a metal core in their center. And especially for the Earth, it's the source of our magnetic field. But we don't know a lot about our core. What we've learned about it, we learn indirectly because we can't go there.
It's too hot. The pressure's too high. Our instruments would melt. Can't drill a hole that deep in the Earth or other planets. It turns out we can study a planetary core out in space because there's this one object. It's one object called Psyche.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
It is the only asteroid that we're aware of that is 95% metal. It's about 200 kilometers across in one axis.
So it's about the size of Massachusetts.
It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
The first thing that came actually was the theory. Some people from Jet Propulsion Laboratory contacted me and said, we would like to plan a mission that would test your hypotheses.
And that starts you down a road that takes years. So we wrote a proposal to send a NASA spacecraft to visit this big ball of metal. And then about a year ago, Lindy gets a phone call. You win. And then we're all like, oh my God, now we have to do it.
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do. And it would be the first.
We've been approved to go in August of 2022. So we talked with our mission design and navigation team, and in fact, they were able to come up with what is probably the most optimal trajectory, doing a Mars flyby.
Flies past Mars, gives us a gravity assist, uses that propulsion system to then slowly creep up toward the end of 2025, getting there in early 2026.
SSL is building the solar electric propulsion chassis. When we do the mechanical, physical integration of each instrument on the spacecraft, we'll work hand in hand with each of the providers to get out to Psyche and do a full discovery mission.
We've figured out a way for many, many people to build something together so complicated, no one person can understand it, but it all has to work together perfectly for decades without fail.
Just the fact that these things work at all is a thrill. It's just a testament to the engineers that we collaborate with, that they can build these things.
It's exciting for me to be able to be a woman winning and leading a deep space mission. The only previous woman who competed, won, and led a deep space mission was Maria Zuber, who was my friend and mentor at MIT. And so my drive is to make everyone feel welcome and to have every voice heard. We want as many undergraduates as we can. We want to involve as much of the public as we can. We want people to feel like this is their mission.
You get that first picture back, and one of the first things that goes through your mind is, oh, thank God I didn't leave the lens cap on. We will put our pictures out there as soon as they come down. So we'll discover at the same time that the public discovers. We'll be scratching our heads and it's like, I don't know what's going on. At the same time, everybody else is like, wow, what is that? I don't know, let's figure it out.
I did get to look at Psyche through an optical telescope in my backyard. Some wonderful It's a very, very tiny, faint dot. And that made a bunch of us cry to think that we could send something to investigate that speck of light.
We can understand this universe that we live in. We can explore it, we can learn about it, and we can be a part of something which is much bigger than just us or just this planet. We will see new things when we visit a world made of metal.
Welcome, everyone. My name is Mark Razzie from the Public Services Office at JPL. I want to thank you all for joining us for this edition of the Von Karman series. As you saw in our intro video, tonight we're going to be talking about Psyche, both the asteroid and the mission. The asteroid is potentially the core of a former planet, and the spacecraft will be sent to explore it. Helping me out tonight is our co-host, public outreach specialist, Lindsay McLaurin. Hi, Lindsay.
Hi, Mark. Thank you so much for having me tonight. And to everyone watching from home, we just want to remind you that this is your space program, and we really want you to be involved in the conversation tonight. So from wherever you're joining us, use the chat feature to ask questions, and one of our members of our amazing social media team will get them to us. We'll try to answer as many questions as possible, and for some reason, if you don't see the chat, simply refresh your browser and it should be there. Let's get started, Mark.
Thank you so much, Lindsay. So to tell us more about both Psyches is our very special guest tonight, the Psyche Principal Investigator, Dr. Lindy Elkins-Tanton. Good evening, Lindy. Thank you so much for joining us tonight.
Hi, it's great to be here. Thank you so much.
Oh, it's our pleasure. It's our honor. Thank you. So one of the first questions I like to ask when we do these things is, for all the students out there that might be watching, tell us about what inspired you to become a scientist.
You know, I think in some ways I was kind of born a scientist. I grew up in a family where we were just interested in, I guess the currency of our family was interest. And so be interested in music, be interested in art, be interested in nature. And my dad would walk us around the yard and teach us the Latin names of plants and stuff. The thing I didn't know was what kind of scientist I wanted to be. And maybe I'm still not totally sure what kind of scientist I wanted to be. But it came along and I moved kind of from biology to earth science and then into planetary science. There just are always bigger and bigger questions to ask. And that's the thrill of science to me.
Oh, that's cool. That's a great answer. So let's get back to the project then. So being the potential core of a planet, I think the appeal to explore Psyche just might be obvious. I mean, that's the coolest thing ever, the core of a planet. But, right? I mean, that's just crazy. But how did you get involved in the project?
Well, I had really never contemplated leading a mission or proposing a mission in the hopes of leading a mission. But I was studying how planets form. And my friends and colleagues and I, Ben Weiss and Maria Zuber, and I wrote a paper that had to do with the formation of the very first tiny bodies in the solar system. These are called planetesimals. It means tiny planets that were just tens to hundreds of miles across, and they formed really fast early in the solar system. And they basically were the material from which our big planets were built. So I wrote a paper about this and got an email from a couple of guys at JPL, Daniel Weinkert and Bruce Bills, saying, let's propose a mission to test this hypothesis. That's what I was talking about in the video when I said about testing our hypotheses. And so we started working on it then. And we didn't even know, we weren't even focused on the asteroid Psyche at that moment. We were just looking for a place to learn about those early planetesimals. And we decided in the end that this mysterious, really truly unknown asteroid Psyche was the place to go.
Oh, that's super cool. That's got to be such a great feeling to have your proposal accepted and know you're going to start this journey. So cool. So tell us more about it. Tell us more about the mission.
Yeah, well, as we famously always start these descriptions, that Psyche is both the name of the asteroid and the name of the mission. We were trying to make it really easy for people to remember what it was about. And so it's a robotic spacecraft, and our launch period opens in under a year on August 1st, 2022. That's our first option to launch. We're going to launch, we will cruise through space for 3.4 years until we reach the asteroid, and then we're going to orbit it for 21 months and try to figure out what it is. And we've been describing it so far as maybe the core of a planetesimal that got some of the outside rock knocked off it through collisions. But the truth is, and here's something I'm going to say a couple times, we don't really know. We don't really know. All right, so let's talk about, shall we go to the slides now?
Go for it, jump in.
All right, so what we're showing you right here after that little intro is the Orientali Basin on the moon. In case any of you thought this was Psyche, this is not Psyche. We haven't seen Psyche in anything like this detail. It's on the limb of the moon. It's not quite in sight of the Earth. And this is my favorite lunar impact basin. I encourage you to have a favorite basin. This is a really good one. We have this photo thanks to Lunar Orbiter 4, which is a robotic spacecraft. It took this photo in 1967 when I was 2. And with other robotic spacecraft, we've explored many rocky bodies in our solar system. That's the point of my starting here. A primary rocky target besides the moon is, of course, Mars, which I'll show on the next slide. And so here is Burns Cliff on Mars, photographed by the rover Opportunity in 2004. Roger Burns, for whom this was named, was a wonderful person and someone I knew. I took classes from him when I was an undergraduate. So these places, the pictures of the moon, the pictures of Mars, familiar from decades of photographs, they begin to feel like part of our natural landscapes. We've also visited planets made of ice or gas like Jupiter. On the next slide, we'll show you the beautiful red spot shown, a photo taken by the Juno spacecraft in 2019. And we visited icy moons like Europa on the next slide, shown here in a photo taken by the Galileo spacecraft in 1996. And so rock and gas and ice, but not yet have we ever visited a metallic world, a world that had metal on its surface. So this is the point I'm trying to make here, is that these images become familiar to those of us who love space, but we don't have any photos of Psyche. So in the next slide, I'll show you what we think that the asteroid 16 Psyche is. We think it's largely made of metal. There are about 40 asteroids classified as M-type, meaning their reflected light spectra, the light that reflects back to the Earth, look the same as Psyche's. And of those, only about 10 are candidates really to be made of metal, and Psyche is the largest of these. We think that Psyche is actually between 30 and 60% metal. And Tracy Drain, our fabulous, she was our deputy systems engineer. She's gone on to work on Europa Clipper. In that video, she said maybe 90% metal. And at the time we wrote the proposal, that was the best data. Now it looks like maybe 30 to 60% metal. Although if it has a lot of pore space and fractures and it's really a rubble pile, it could be still as high as 80% metal. We don't know. And so what else won't we know until we get there? Well, almost everything. Most especially, we won't know what the asteroid looks like until we get there. We have no images of Psyche that were taken closer than from the Earth. And so this is an artist's impression by Peter Rubin based on our best scientific ideas. Now, here's what Psyche really looks like from Earth. If you move to the next slide now. This is this photo of Psyche that was taken from my backyard back in 2017. Just after we were selected and we knew we were going to really do this. Although honestly, Psyche doesn't look that much different through Mount Wilson's 60-inch telescope. It's just a point of light so far away. And of course, that's what the word asteroid means. It means little star, because that's what they looked like to the first people who discovered them in the early 1800s. So even though it's just a point of light, Psyche is large as asteroids go, as you'll see in the next slide. Psyche is not quite a sphere, but if it was, its diameter would be about 226 kilometers. And here's how this size compares to the distances between cities in Southern California and in Arizona, where I live. Psyche is about the size of Massachusetts without the Cape. It's just a little smaller than Switzerland. And so let me show you now the very best images we have of Psyche. These images on this next slide are taken using SPHERE, the Spectropolarimetric High Contrast Exoplanet Research Instrument, here turned not toward exoplanets, but toward this little asteroid Psyche. It's part of the European Southern Observatory. Now, these are pictures of Psyche at different times. So you can see how the shape apparently changes as Psyche rotates, which Psyche rotates every 4.2 hours. Also, by the way, it goes around the sun once every 4.99 years, just about 5 Earth years. You can see that Psyche is really more of a potato shape than it is a sphere. And so one of the main questions we have, obviously, as I've been talking, it's probably becoming clear, is what is Psyche made of? From the characteristics of its reflected light spectra, almost all the researchers who studied it think its surface is largely made of metal. And the density of the asteroid is high, meaning that it can't be made just of rock. One thing we can do is compare the density and the spectra, that reflected light, of meteorites we have here on Earth and see if any of them match the asteroid. Most meteorites that fall to Earth have come from the relatively recent past from the asteroid belt. And so the meteorites we have, only a few of them come from Mars or the Moon. Most of them come right from the asteroid belt. So there's one really interesting match with meteorites that matches Psyche in the next slide. These are very strange meteorites called the CB chondrites. In these two samples, the light gray that you see is iron nickel metal, and the darker parts are silicate rock. There is a lot of metal in these meteorites, and their density and their spectra is a good fit for Psyche. But because these two samples in the pictures here are really hand sample sized, they're not the size of an asteroid, here it looks like the rock and the metal would be very intimately mixed. It's also possible that the metal would appear in great patches if it really is the part of a core. We don't know. And so how might a metal-rich body like Psyche form? Let's talk about the theory in the next slide. Now, start at the top left, that big green circle on the top left. Very early in the solar system, as I mentioned, the equivalent of just the first few seconds if our solar system were a year old, tiny planets called planetesimals formed. These planets, as I was saying, were just tens to hundreds of kilometers in radius, so around the size of Psyche and the other large asteroids. Some of the planetesimals had enough short-lived radioactive elements in them, particularly this element aluminum-26, that the heat of the radiation actually melted them, like I'm showing in the top left image here. Inside these melted planetesimals, the liquid metals drained to the center because of their density, leaving the rock that I'm showing here in green outside. That's what you see there. And that process is called differentiation. The planetesimal differentiated into a metal core and a rocky exterior. So how do you create an asteroid with a metal surface from this starting point where the metal is really deeply in the interior? We assume in our simplest model for what Psyche might be that multiple impacts struck the planetesimal and smashed off parts until the core was revealed, as you see on the top right. That's our top hypothesis for what Psyche might be. We still think that is the simplest way to explain a body the size of Psyche that has a very high metal content. We think it's still a remnant, a cracked open remnant of a planetesimal. But if you look at the bottom, there's also the possibility that Psyche might be a planetesimal that never melted and differentiated. Here with these brown layers, I'm indicating it just heated up, it never melted. Very few meteorites from unmelted parent bodies have the right spectra or enough metal in them, but it's plausible that Psyche might be the battered remnants of something that never melted but was just very high in metal. And in a way that would be even more surprising. And so to summarize, Psyche might be a battered, differentiated planetesimal showing its core being revealed from impacts, or it might be an unmelted, undifferentiated planetesimal with a lot of metal in it. So either way, this is surprising. And maybe it might be clear at this moment to say why this is so intriguing to me. Because that top hypothesis, it melted and differentiated and then was battered until the core showed, is pretty unlikely. It takes a lot of coincidences, many strikes that knocked rock off without breaking it entirely apart or without mashing it into a larger body. There's a little bit of unlikeliness in that top one, but the bottom one where it didn't melt at all, but it still has a lot of metal, we have very few samples that match that either. So either one of these top ideas is pretty unlikely. And so the key message I want to give you right now is though we have these ideas, they're based on data, they're based on good theory, they're based on models. We do not know them to be correct. And when we get there, we will be surprised. It will be something we're not expecting. So now in the next slide, you can see what we were depicting with our cover art of our Step 2 proposal before we won. This was the cover art, also by Peter Rubin. This is just after an impact between two planetesimals. You can see the impactor screaming off to the bottom left, and at the top right, you see the red-hot metal core of the planetesimal being revealed from under shrouds of disturbed rock. So maybe this is what Psyche is. So let's move on to the mission itself. The Psyche mission is led out of Arizona State University, which you'll see in the next slide, where I am, and managed by Jet Propulsion Laboratory. And our industry partner who built the chassis and the solar electric power system for the spacecraft is Maxar. We have 3 science instruments we're going to fly, the payload, and a gravity science experiment. The gamma ray and neutron spectrometer, a kind of instrument I really didn't know much about before about 10 years ago, will tell us the elemental composition of Psyche's surface while we're in orbit, and that's being built by Applied Physics Lab. That instrument has recently been delivered to Jet Propulsion Laboratory to be integrated onto the spacecraft, and it is just about the finest one of its kind of instrument that's ever been built. We're really excited about how that one's turned out. Full job. The imagers, that is the cameras, come from Malin Space Science Systems and Arizona State University. And the magnetometers, with which we'll find out, did Psyche have a magnetic field? Did it once have a core dynamo the way the Earth did, maybe? Come from Danish Technical University, and the gravity experiment is led out of MIT. So these 3 experiments and the gravity experiment together are enough to be able to answer these questions we're asking about Psyche. They were extremely carefully selected to be able to together decipher what Psyche might be, considering the very broad landscape of possibilities. Because if you think about it, think back to those first slides I was showing. We've been to the moon many times. We've been to Mars many times. We have many, many photographs of these places. It's seldom that we go to a place where we have no photographs and we don't know what to expect. So that's what we're doing. We've worked really hard to unite these sub-teams into one transparently communicative team. And one of our big successes is JPL and Maxar, who've developed ways to work really seamlessly. We're very excited that Maxar is lending the solar electric expertise to JPL's expertise in this area. And we are sending the first Hall effect thruster outside of Earth-Moon orbit. So in the next slide, you'll see how big the spacecraft and how it will look after it unfolds its solar arrays once it's in space. You see the person to the left. It's about the size of a singles tennis court, and the solar arrays will produce 20 kilowatts at Earth orbit, and only about 1/10 of that by the time we're out at Psyche, because the sunlight is so much weaker at that distance. The next slide, you'll see an image of a SpaceX Falcon Heavy launch, and we are going to be on a Falcon Heavy for our launch out of Cape Canaveral. SpaceX will be attempting to land the boosters. That's a real personal thrill for me. And again, our launch period opens August 1st, and so keep your fingers crossed. We have so much work to do between now and then. So in the next slide, how do we make all this work? It is all about the people. People make all the miracles, and people make all the tragedies. So much of our effectiveness and success depends upon how we treat each other. Positive team culture matters. It matters because when everyone is invited to be heard, then more ideas are available, calmer heads think better, and better decisions are made, and therefore project risk is reduced. It's actually a significant way to reduce project risk. This is a photo of just a small part of the team here in front of a Maxar building at our Step 2 site visit before we won. We've worked very hard to create this culture where we share our challenges and errors willingly and help people step in to help. Our relationship with NASA headquarters has been especially positive and supportive, I think, as a result of this policy. We have an unofficial motto, which is the best news is bad news brought early so we can do something about it. So think about that fundamental astonishment of being able to create a robot so complicated that no one person understands all of how it works. This is this giant step in human evolution, the ability to create a mechanism this complex and successful. And I think part of the reason we explore space is to show how bold and brave we can be as a species and what we can do. So if we can do this, think of what we can do here on Earth. The next slide, the next to last slide, I'll show you that we are dedicated to outreach and student engagement for all of these very reasons. If you look at this graph on the horizontal axis, the one along the bottom is the timeline from the time we were selected in September. Actually, we were selected in January of 2017, but right that year when we got student collaborations going in September, all the way up to May of 2021. And on the vertical axis is the cumulative student participation. Every horizontal purple line is one student, and the length of the line shows the time period over which they were involved. So mostly students are involved during the school year. These are college and university students. But some students have gone on to work. In fact, some have been with us through the whole mission so far. Since we started in September of 2017, 9 months after selection, we've had almost 900 students participate in our 4 student collaboration programs. We have capstone projects where they're given real problems the Psyche mission is facing, from hardware to software, public engagement, and science. We have 11 universities working with us with capstone teams. We have a Psyche-inspired art program. We compete and then choose 16 student artists every year, and they're supported then to create original artworks that have to do with space exploration and Psyche and being part of a team. We've engaged 30 universities in that program. We also have free online courses in the evolution and life cycle of a space mission and in creating inclusive teams. And those are available through our Psyche website, which I will show you on the next slide, our final slide. I want to thank you all so much for your time today, and I hope you'll join us on Twitter, Facebook, and Instagram, and on our website for Psyche, the journey to a metal-rich world. Thank you so much.
Wow, Lindy, that's amazing. Thank you so much for sharing that with us and blasting through it in that short amount of time. So I think we'd like to go to see if we have any questions. So Lindsay, how are things looking out there in the social media world?
We have had an abundant amount of questions for you, Lindy. The first one is going to come from Finn on Facebook. And he was wondering, how do you determine what this particular rock is metal rich or likely to be?
That is such a great question. How can we possibly tell from here what Psyche is made of? Well, the first clue that people have been looking at now for over a decade is the density of Psyche. It turns out we have ways to tell when asteroids have very small gravitational interactions with other bodies. And by guessing at their size, estimating their size, and knowing the gravitational interaction between bodies, we can know both their volume and their mass, and that gives their density. And if you remember those best images I have of Psyche that I showed, the many different images of it rotating, you could see how using a computer model, you could get the volume of Psyche from those images. So then we get the density. And we know how dense rock is. We know how dense metal is. Metal is twice as dense as rock. Yeah, we're going to go look at those pictures, which is great. I think that they're earlier than you started. There we go. Those guys. So using a computer model of those, you can estimate the volume. And looking at the gravitational interactions between Psyche and other bodies, you can get the mass, and that way you get the density. And I should say that this team, Beacon Koski, has done a super job, but there are 3 or 4 other teams who've also done it independently. They agree within, say, 10 to 30%, so we don't really know exactly what the density is, but we know Psyche is too dense to be just rock. It has to be rock plus metal, so we know that for sure. And then the next thing we do is we look at the reflected light off the surface. You can just look at it through a telescope and analyze the light that comes in the telescope and see whether it has the same spectral characteristic as sunlight, or if material on Psyche is actually absorbing some of that light rather than reflecting it off. And we can compare that spectra to meteorites and to pure materials. This is work that Jim Bell and Stephen Dibb are doing at ASU in particular, and it does look like the spectra matches something that is very rich in metal. So those are 2 really good ways. You can also look at radar bounces, if you can believe it. We can actually bounce radar. Sadly, this was done mostly with Arecibo, now crushed through the loss of its towers. This is, to me, a miracle. Anybody who's listening who doesn't know about this, maybe you'll be as amazed as I was when I first learned about this. They can actually bounce a radar beam from Arecibo off of Psyche 3 times further from the sun than Earth is, and catch the return from the reflection off of Psyche and tell things about the characteristics of its surface from the kind of radar that's returned. So all those pieces of data, amazingly gathered by us here on Earth, indicates that Psyche is largely metal.
Lindsay, do you have any others?
Yes, our next question comes from Medea27 on YouTube, and they would like to know, how do you manage the integration of the work of so many different teams?
Oh, Yeah, this is something I'm learning about because it's not something I was trained in. For this, you need your professional project manager. For us, it's Henry Stone at Jet Propulsion Laboratory, and you saw him in that video. Fantastic person to work with. You could imagine how much study has gone into the theory of how you get teams of people to work like this. And one of the ways that it happens is through the system of requirements. So starting from the very top, there are 5 main science things we want to answer on this mission. And we write down exactly what measurements we need in order to answer those 5 science questions. And then what we need to build for an instrument in order to make those measurements. And then what kind of spacecraft we have to build in order to support those instruments. And you go on and down in detail until you have requirements for every single little part of the spacecraft that needs to be built. We have over 2,000 requirements for the mission. And we check on every single one of them. And all the teams that are building the spacecraft are united through this requirements tree to make sure that we build something that works exactly how we want. That's one little part of the theory of project systems management that goes into this. At our peak, we had 800 people working on the team. And so, to my sadness, I don't even know everyone's name, let alone be able to recognize them. But we have this way of bringing everybody together. I think it's astonishing.
Thanks, Lindy. Our next question comes from Ethan on LinkedIn, and he would like to know, why do you suspect that Psyche is an old core?
Why do we suspect it's an old core? Yes. All right. So it goes back to that question of, if we believe that it's mostly metal or largely metal, we have to ask ourselves, how in planet formation anywhere in the solar system do we see a situation where metal is really collected together in high concentration? If you walk around on the surface of the Earth and you pick up rocks, very few of them are rich in metal. You have to go to special places, where there are mines and things like that. And it turns out that here on Earth, on the surface, when you find something that's made of a lot of metal, it's usually because of the processes of water here on Earth. And so that doesn't really apply to us. So on the planetary scale, how do you get a lot of metal? Well, the best way that we know is by core formation, this process of melting and the sinking of that dense material to the inside of our planets. That's what's inside the Earth, of course, a great big metal core. For the Earth, the inside of the core is solid metal and the outside is liquid metal. That's how we get our magnetic field. The magnetic dynamo is formed by the mixing of that liquid outer core. And by studying how planets spin and what their densities are, we know that there's a metal core inside of Mercury and Venus and Mars and the Earth, and also inside the Moon, there's a small metal core. So that seems like the most common planet forming process that concentrates metal. So that's why it's our top hypothesis. But don't forget that there are these funny meteorites that also have high metal contents that never melted. They just have a lot of metal. Maybe they formed close to the sun. That's possible. We might really learn about solar system processes that have to do with clumping up those first bits of dust and pebbles, maybe in a metal-rich way that we haven't quite figured out before. Maybe that's what Psyche is. But really what it comes down to is that creative aspect of science. We're pretty sure there's a lot of metal in this asteroid. Now, what are all of the processes we can think of that are chemically and physically plausible that would cause a lot of metal to come together? And these are our favorite ones. And I ask scientists in talks that I give all around the world, how else could Psyche be made? And so we collect these ideas and we encourage people to think about it, because probably it's something we haven't even thought of yet.
Great, thank you, Lindy. Tim on YouTube asked, do you have any idea what the mix of metals on Psyche might be?
Well, we go for what the simplest possible answer might be. And if you think about core formation, we're almost certain that the Earth's core, we're as certain as we could be, there are many different indirect ways to measure characteristics of the Earth core. And it seems like it's mostly iron and some nickel, and then a smattering of other light elements. So iron is the most common heavy element that goes into metals in the solar system. And so that would be your top candidate. And then you look for other kinds of metal that might like to dissolve into iron. And then you look at the iron meteorites that fall to Earth. there are meteorites that fall to Earth that are made almost entirely, or in some cases entirely, of iron and nickel metal. So that's what we think Psyche is. We think those iron meteorites that fall to Earth are parts of cores of little planetesimals. And I'm talking about hand samples or boulders the size of your desk. And in a couple of cases, there are even bigger ones like the size of a garden shed. And they're all iron nickel metal. It's mostly iron, maybe 2 to 10% nickel. There's copper. And then there are other kinds of metal elements mixed in as well. So we look at that. What's the simplest answer? The simplest answer is that it would be like these meteorites or like the Earth's core.
Great, thank you, Lindy. And our last question will be, from Musical Wolves on YouTube, will a return core sample be made?
Oh, I wish. Yeah, and no, we're not doing a sample return, sadly. And so I hope that you all have been following with great interest the OSIRIS-REx mission that's gone to this small, fascinating asteroid Bennu, and they're bringing back a sample, and the Hayabusa missions from JAXA, the Japanese Space Agency, that are bringing back samples. And those are from bodies like asteroids and other bodies that are quite close to the Earth. Psyche is very far away. It's way on the other side of Mars. It's actually closer to Jupiter than it is to Mars. And to send a spacecraft out there, land, take a sample, take off again, and come all the way back to Earth would be so expensive that we could not possibly afford to do it in the budget that we've got. And so NASA famously says that they start by doing a flyby of a new object, and then you do an orbiter, and then a lander, and then a rover. That's kind of the process by which you learn enough about a body to always take the next steps. Well, we're kind of skipping the flyby with Psyche, and we're going right to orbiter. So we'll orbit for 21 months, but the spacecraft will not return to the Earth, and it will not bring any samples back to Earth. And I just started today. I started a little Twitter series, myth busting about Psyche, because there's a lot of speculation about it in the press, and I'm here to tell you that Psyche is really never a target for returning to the Earth. It just would not comprehensively be economically feasible to bring it back. So Psyche is never, ever, ever going to come back to the Earth, sadly.
Lindy, thank you so much. Lindsay, thank you so much. That's all the time we have for questions tonight. But do you have any parting thoughts for our audience tonight, Lindy?
Well, I'd like us to think a little bit about the miracle that is the fact that we humans can explore space and what it can do for us. I love to think of what we're doing with Psyche mission and the other robotic missions we're sending as being on behalf of all of humankind. So in that video, when Jim Bell says, we're going to put these photos up on the internet immediately for everyone to see, that's right. We've already been building the software pipeline such that within a half hour of our receipt, the images of Psyche are going to be free for everyone to look at on the World Wide Web. We're not going to curate them. We're not going to save them for the science team until we publish or not publish something that we think looks, I don't know, weird or unexplainable. It's all going to go out there so we can all look at it at once. Because I would like space exploration to be something that unites us and shows us more about where we are in our solar system, our perspective of ourselves and this planet. We live on a planet. It is our precious planet. And we as a whole species, not just as a country or as a single people or as people from a single city, we all have the responsibility for it. And I think by looking out, that helps us figure out what we should do at home. And I really mean that. It sounds like a little bit high flown, but it's very heartfelt. And that's what I hope that we do with Psyche mission.
That's awesome. I know, for one, I can't wait to see the images and to see what the science is and what this thing is really made of. So, ladies and gentlemen, that's all the time we have tonight. A big thank you to our guest, Lindy. We really do appreciate you giving us some of your time tonight. My co-host, Lindsay, thanks for monitoring and managing the questions tonight. Of course, all of you folks behind the scenes that make all of this happen, and all of you for watching. Please join us next month when we talk about how engineers make the science possible. Should be a good one. Stay safe, stay well, and good night.